Okay, let's do example 4, inverse sine of negative 1/2. Now, when I visualize this on the unit circle, I'm going to visualize where is the y value of the right triangle negative 1/2. That's right here. Now, in normal circumstances, I might want to think that this is a positive angle of 11 pi over 6, but because we're doing the arc sine, we have to restrict the domain, or I should say the range, to between negative pi over 2 and pi over 2. Well, there's only one function, one angle here that has a reference angle of pi over 6, so this angle is negative pi over 6. So the answer here is negative pi over 6. It has to fall between negative pi over 2 and pi over 2. Okay? All right. Also, I'd like you to remember when you take the inverse sine or the inverse cosine or the inverse of tangent, the arctan, we are finding an angle measure based on a value of the trig function. So the trig function is negative 1/2. The trig function is negative root 3 over 2, etc., etc. So if I want to find the arc cosine of negative root 3 over 2, let's visualize that on the unit circle. Okay, where is the cosine negative root 3 over 2? Well, it would be here at this angle here, because this value is the long one and this is here. So we know we are restricting between 0 and pi with our angle. So because we're restricting between 0 and pi with our angle, the only angle that's possible for the answer here for the arc cosine of negative root 3 over 2 is 5 pi over 6. This has a reference angle of pi over 6, but it has to be between 0 and 2 pi. So this is negative root 3 over 2, the x coordinate here. The y coordinate would be positive 1/2. Okay, so 5 pi over 6. Now 5 pi over 6 is not a possible answer for the inverse sine of 1/2. That would have to be pi over 6 over here. Okay, because for arc cosine, I'm going to do this in another color here. We'll do this in green. The arc cosine, the values will be between here and here. For arc sine, they'll be between here and here. This rotated angle from negative here up to pi over 2 here. Okay. Now we're going to look at the cosine inverse of the cosine of 3 pi over 2. Now, there's this obviously common term of starts with a C and ends with Ansel, that cosine inverse and cosine seem like they're just going to cancel and give us an answer of 3 pi over 2. The trouble is that the cosine of 3 pi over 2 is the answer of 3 pi over 2 is outside of our domain from 0 to pi. So if you visualize this, okay, so we're just going to take this rotated angle all the way around to here to 3 pi over 2. So we're going to take the cosine of 3 pi over 2. Well, this point is going to be 0 comma negative 1. The x coordinate is 0. All right, 0. That means this value is 0. So what I want to do is take the cosine inverse of 0. All right, well, between 0 and 2 pi, there's only one place. Let me do this in blue. Actually, let me do this in red. There's only one place between here and here where the cosine is 0, and that's right here, 0 comma 1. This x coordinate is 0, this x coordinate down here is 0, but the only one that's the answer is pi over 2. So this will occur only at pi over 2, and that's your answer. And again, when you do the sine of the arc cosine of something, you think they're just going to cancel each other. Maybe they will, maybe they won't. So you got to be careful about using the restricted domain. Okay, so let's go ahead and try these problems, and then I'll put the solutions up and you can see how you did. All right, so I'm not going to show you all the answers first. I kind of think I have to walk you through some of these. Some of these are challenging. I think the arc cosine of root 2 over 2 is pi over 4. That's in the first quadrant. That's pretty straightforward because it's between 0 and pi, so we're going to get pi over 4. Sine of pi over 4 is root 2 over 2. So this one's pretty straightforward because the sine and cosine of root 2 over, or the sine and cosine that are root 2 over 2 or have the same angle, that's pi over 4. Okay, now the sine inverse of 1/4. Now this can be a little bit tricky, but you can visualize this with right triangles. Okay, whichever quadrant it's in, you can use the same SIGN. This is positive positive, and this is negative positive here, and down here is positive negative. So wherever we are, that's what we can look at. Now in this case, we're looking at 1/4, the sine inverse of 1/4. The sine inverse of 1/4 represents this. So when I'm taking this right triangle here, what I have is this 1/4 and something else. This is the x value that I have here, and using Pythagorean theorem, I got 4 squared equals 1 squared plus x squared. So x is equal to the square root of 15. Okay, so I don't know what this angle is, and I don't care. I'm going to call it theta. So this theta, I want to take the cosine of that theta. Well, that makes this the square root of 15. The cosine of that angle is the square root of 15 over 4, which equals the square root of 15 over 4. Do this on the calculator just to verify my answer. All right, cosine inverse of 1/5. Very similar type problem. We're here and here, okay? So we're going to have a 1 and a 5. All right, so when we visualize this, this is between 0 and pi. I don't really care what it is. It's some value. All I know is that when I take the sine of 90 degrees minus whatever this angle is, this is an angle, I'm going to get the actual cosine of that angle. So the sine of 90 minus theta versus the sine of pi over 2 minus theta is just equal to the cosine of theta. Okay? So this is the cosine of whatever this angle is here, right here. I'll point at that right there. Well, the cosine of that angle is 1/5. So the answer there is 1 over 5. Okay, so here I'm going to take the tangent where sine is negative root 3 over 2. Sine inverse of negative root 3 over 2 is down here where I have this y coordinate, and this is between 0 and, or excuse me, negative pi over 2 and pi over 2. So this is actually the tangent of negative pi over 3. Okay, again, you might be tempted to do a positive angle, but remember when we take the inverse sine, we have to restrict the domain between negative pi over 2 and pi over 2. All right, so this is negative pi over 3. When I take the tangent of negative pi over 3, I'm really just taking the sine of negative pi over 3 over the cosine of pi over 3, which is negative root 3 over 2 over 1/2, which is negative square root 3. I'll leave the the nuances and details to you, but if you have any questions, of course, bring them to class.